Do you remember talking about those 12 basic functions? And I just want to review a few with them right now, because if we don't review them, they won't stick. Your brain prunes information that it feels like it doesn't need. How can your brain tell if something is not very important if you never go back to it? Like that little kid that used to live across the street from you like 12 years ago, and then you moved, and now you don't know their name anymore. That's okay, because you're probably never going to see them again. Okay. Point is that your brain probably pruned that information because it didn't need it, and that's the neural scientists would use the word pruning. Anyway, you are in danger of pruning out these 12 functions, so I just want to take a minute to talk about them. Identity function is the y equals x one. Remember that one? Okay, this function over here, do you remember what it's called? Y equals something. 1 over x, very good. And it's got those dotted lines that you get close to and never touch. What are those called? Asymptotes, good. Next thing, the basic logistic function. That's the one that starts out at 0 and then slowly rises through 1 and then, actually, no. I've drawn this slightly wrong. I better try this again. I really should be zoomed in closer because it goes up and it maxes out at 1. And it's got an asymptote there. It gets closer and closer to 1, but I won't touch it. Same thing on the bottom. It has an asymptote at 0. So the basic logistic is kind of confined between those two things. Okay, the next one's a natural log function. And that is like, I try to help you remember, it looks sort of like a tree that's been blown over in the wind. And kind of had a strong wind blowing this way. And when a tree blows over, you call it a log. And it lays on the ground, right? Okay. So this one's the log function. All right, next one. The greatest integer function. That's kind of like your age. Have you ever thought it's weird that you don't get to be called 3 until you are exactly 3 years old? And then you're called 3 for an entire year until you hit age 4. Know what I mean? You're really not 3. You're, okay, for you guys, some of you guys are like 16. You're really not 16. I bet you there's nobody who's exactly 16, right? You're all a little bit over 16. And if you aren't 16 yet, it's because you're still 15. It's like the greatest integer function. It stays the same until all at one moment, boop, it jumps up, and you aren't 1 anymore, you're 2. Okay? Or a baby. You don't say they're 0 years old, do you? You don't say they're 1 year old, though, do you? So what do you say for a baby? You say it in months, okay, because it makes more sense then. Because that's where our system breaks down of saying I'm 1, I'm 2, I'm 3, I'm 4. The little kid, well, they wouldn't be able to say how old they are. Anyway, they're a baby. But if you shouldn't say how old the baby is, you don't say, well, it's 0. That doesn't make any sense. So we say it by months. All right, so the greatest integer function, that's one example of where you'd ever use that. Okay, exponential growth. You've seen it before. It's growing really, really fast. Steep growth. It's like multiplying by something. Like if I had 2 rabbits, and then they turn into 4 rabbits, into 8 rabbits, into 16 rabbits, and pretty soon you got 64 rabbits running around, and it's grown really fast. Okay, that's exponential growth. All right. Next one, sine function. Sine's a wave. It goes back and forth. It maxes out at 1, and its lowest it goes is -1. So it's sort of like there's asymptotes here, but they're not asymptotes, because asymptotes are things you get closer and closer into and never touch. This is a cycle. It goes up and down between 1 and -1. Same with cosine. They're pretty much exactly the same. Sine starts at 0 and only goes up from there. Cosine starts at 1, and it's all downhill from there. Hopefully for you, you're not all downhill from here. You guys won't reach your physical prime until you're probably 25. So you're at least not all downhill until you hit that. You probably won't hit your mental prime until you're 30, maybe 35. And you can stretch for kind of a long time and have your mental prime last a long time. There's some still really sharp, older people. Physically, top out around 25. Okay, anyway, piecewise functions. This one's a piecewise function. It's this on the left side, which is the absolute value one. It's this on the right side, which is the quadratic one. So how would I write the function? Well, you start by saying f of x equals, and it equals different things at different times. I do those really bad unless I concentrate. Let me try again. There. Okay. I'd like you to write me what you think the function is for this. This is a piecewise function. It's two parts. It's this from here to here, and it's that from there to there. In case you forgot this, you need to remember it. Now, some classes, if you are listening to this video at home, have not talked about piecewise functions, but we have. If you've been following my videos, you already had a day on this earlier. And so we're just reviewing it to make sure it sticks. Yes, sir. That's a good question. I was going to talk about it, but I'm going to say, since you asked, I'm going to say that the blue one is hitting 0, and the green one is empty there. That was a good question. Okay, so I was going to write this function. First thing I do is figure out what it is on the left. That's an absolute value. So the function is the absolute value of x between negative infinity all the way up to 0. And does it work at 0? No, so it was a curve. And it is the squared function from 0 to infinity. And what have I done wrong? I need a bracket on that 0 because it does work at 0. Okay, so this is the first part of the function, which is right here. And this is the second part of the function for this part right here. Any questions about that? That's what a piecewise function is. It's lots of little functions put together to make one big function. All right. It always has to pass the vertical line test too. So when I'm all done looking at this, I would take a vertical line like, let's say, this, and say, does this vertical line ever touch it twice? And that's the important point. The endpoints usually are where people screw it up. And nope, it doesn't ever touch twice, so vertical line test is passed. That's a good sign. Okay, on to this one. This is another piecewise function, and here's generally how you do them. The blue one there, negative 2x plus 1 is this blue line in here. Okay, and that's only supposed to be that blue line between here and here. Then the red one, which is this x minus 1 squared, it's the parabola. The whole parabola is graphed. So you graph both of them completely, and then you go back and you erase the parts you don't want. Okay, so this is to limit my area down to just between negative 2 and 1, which is from there to there. And it's supposed to be just the blue one right now, that one right there, in there. So I'm going to erase the blue one everywhere else except there. And I'm going to erase the red one from being in there, because the red one can't be in there. It's only supposed to be the blue one in there. So this is my favorite way of doing these, is I concentrate on just the one function, make the endpoints solid, because they're both or equal to's. Then I go look at the other function, and I say, okay, the other function goes bigger than 1. That means from 1 over, it's the squared function. So I really need to somehow show that this should be 0. Now this looks weird, but it's right. It should be 0 at 1, because if I stick a 1 in here, get how that would make 0? And then it rises from there, like that. There we go. I have graphed my piecewise function. Will it pass the vertical line test? Good. Okay. That's piecewise. Next thing, talking about writing a domain. If you're going to write this domain, there are several ways to write it. I don't even want to say 4. There's 3 main ways that you write this. You could either say a number line. I'm telling you, this is the best way. Make a number line for it. There are other ways, but negative 3, empty spot there. Now ask yourself, at negative 3, does this function crash? No. So it works at negative 3, doesn't it? So I should fill that in. And then from there, does it work as I go to the right or to the left? So what I just did is I figured out the domain of my function. I'm going to start calling that d sub f, domain of the f function. Do you get how that's the big D means domain? It's just a way to write that. That's the domain of f. All right. Now, it's another way to write that. I could say that the domain of f is from -3 to infinity with a bracket and a curve. You get that one? All right. Go back. Okay, here we go. So there's two ways to write a domain. There's another way. I could write this all real numbers where x is greater than or equal to -3. All right, moving on. This one, I want you to write it for me with intervals. It's really hard to fight being tired. Now it's warm in here, but you need to fight it. Sit up, get your pencil out, write this thing down. Write it with an interval. Did you say 5, 6, curve bracket? Good, then you're doing it right. And this is a domain of the g function. You'd write d of g. Okay, just get used to seeing that. All right, next thing. Basic domains. This guy. Why are there no limits on this thing? Because it doesn't have two things. It doesn't have a problem with what? Square roots or denominators. Good. Why could this have a problem? As a denominator. Remember, you'd set it x plus 5 not equal to 0. Remember about this one. You'd solve x minus 4, and you don't say not equal to 0. What do you say? Greater than or equal to 0. And you solve that, and you say x greater than or equal to 4. Okay? And then I've just figured out the domain of f is, I could say it this way, from 4 to infinity, where it could be 4. All right, just showing you some ways to write that. Next. This one always gets people. They think, oh, let's do it the same way. Go x minus 2 is greater than or equal to 0. And you solve and you figure out what x can't be. Why is that wrong? Because it's not a square root anymore. What is it? It's a cube root. And think about this. The point here is that you don't want negatives under square root signs. Why? Because you can't get an answer to that without using fake imaginary numbers. But why is it okay to have a negative when it's a cube root? Because something like that has an answer. What is the answer to that? -2. So this one, even though everybody will end up making a number line and saying that 2 is going to be a problem, or that things that are smaller than 2 are going to be a problem, that's wrong. There's no restrictions. This has no problems because you can have negatives under cube roots. So this one's domain, the domain of f, is from -infinity to +infinity. There's not a problem under that root because it's a cube root. And you can have negatives under there because, again, cube root of -27 exists, and it's negative what? 3. Remember those two. Cube root of 8 is 2. Cube root of 27 is 3. So if I do the cube root of -27, it's just -3. And it's not a problem to have a negative under there. How about this one? What are the restrictions on that one? No restrictions. So it's -infinity to +infinity. Everything will work in there because it hasn't got any square roots and it hasn't got any denominators. All right. If you're going to graph two domains on one line, that's kind of like this. Let's say this is the domain of f. And let's say this is the domain of g. Their child will only work between here and here. So what's their child's domain? From 0 to 5, does it work at 0? Nope. Does it work at 5? Yes. So their child's domain might be like this. Domain of f plus g, or g plus f, either way, is that. Okay. Add, subtract, multiplying, and dividing functions. One thing I think I did badly last time is I used these two functions. And you can't add them together because they're like a square root and an x squared, and they don't add together. So some people started to think that I meant that you wouldn't actually add them together. So I'm going to choose a new g of x, and I'm going to make it something that is more like this. Let's say it's like 2x squared minus 5. All right, so now let's say I'm going to add f of x plus the g of x and make it the child function. Then it's this plus that. Can you actually add them? Yes. Should you add them? Yes. And what do you get for a final answer? 3x squared minus 5. And what do I call it? F of G? No, it's not F O G. But this maybe said it right and I just wrote it wrong. F plus G of X. Are you with me on that stuff? I feel like most of you are. I've just added the two functions together. I put this and this together. I added them up and I got that. That's all there is to it. When I want to check their domains, I check this guy's domain, I check this guy's domain, and I see where they overlap. That's also known as intersecting. All right, so I'm going to go back and look at this for just a second. Another way to say this is that the domain, see if you can handle this. This is the math. This is the hard part, reading it sometimes. That the domain of F plus G is made up of the domain of G and the domain of F and where they overlap. Here's the symbol for where they overlap. Have you ever seen that before? It's called an intersection symbol. All right, so what this means is the domain of G and the domain of F, and this means where they intersect. Do you get the intersection of on a highway is where two roads cross? It's the part where they cross. That's the intersection. Okay, it's where these two cross each other, where they are in common. Okay, so what we're doing when we're doing these adding functions is we're taking the two domains, overlapping them, and seeing where they intersect. This is a crucial symbol. All right, moving on. So, compositions of functions. That was where we did stuff like this, f of g of 3. Okay, we're back from our little 2-second break there. Okay, f of g of 3. Be like the alien. Start on the inside and then work your way out. Got to show you that scene from the movie sometime. It's awesome. Okay, anyway, start on the inside and then you work your way out. So I'm starting in here at g of 3. I'm going to do g of 3. How do I do that? I put a 3 in right there. And I get 1 over, oops, I put the 3 on the 8, sorry. 1 over 3 plus 8, which makes 1 over 11. So I got 1/11. What do I do with that? Put it in where? Right there. G of 3 is 1/11. So I put a 1/11 right there. Now I do f of 1/11. That means I got to go drop this into the f function. So I go drop it in there and there. And then I'll have f of 1/11 is empty spot, drop it in, 1/11 cubed. So my final answer is 1/11 cubed, and I really should cube that out, but I don't know what 11, well, I know what 1 to the third is, that's 1. What's 11 to the third? Somebody with a calculator. 1331, thank you. Okay, so there's my final answer on that one. Moral of the story, start on the inside. Right there. Get the inside done. Once you're done with it, replace it with a number. Say it comes out to 12, then you do f of 12. And you stick that into this function. So you do one function at a time. It's really not that complicated. All right, some notations. I just told you a second ago. What does that mean? Domain of f. This is domain of, and this is otherwise known as f of g of x. What's that? G of f of x, which looks like this. G of f of x. I like it better this way because then I can see what's in the middle. You always start on the inside. All right, so here is a typical problem for today. No, actually, that's going to be for tomorrow. Hold on, I need to back to here and show you a real problem. Here is a typical real problem for today. And over here we'd have like x cubed. And this will be f of x, and this is g of x. And this time, instead of saying what's g of f of 2, where you'd start by finding f of 2, and you get a number, and then you stick it in here, they say what's g of f of x. All right, so this one, I take the start on the inside. got to go back to some basics that I keep on pounding on. You always start on the inside. And replace this with something. Don't you know what f of x is? What is f of x? X squared plus 2x. It's right there. So I can now say it's g of, and I replace this with x squared plus 2x, and now I got g of that. So I got to drop this into which function? The g function, which is right there. So now I'm going to write the g function over again. Oops, got to make it so I can see it. G of empty spot is equal to empty spot cubed. Remember, you replace the x's with an empty parentheses. Then drop in what you're supposed to. I'm supposed to drop this in. So g of x squared plus 2x is x squared plus 2x to the third. Do you actually have to multiply that out? Yeah, you do. And there's a few ugly ones, but you only have like 7 problems for homework today. So the whole point of these problems is to know what to do and then actually to do it. Now I need to cube that. What does cubing it mean? It means take x squared plus 2x times x squared plus 2x times x squared plus 2x. I'm not going to do it with you right now because it'd take forever, but it's first, outside, inside, lasts. Remember, you get that all done. And then whatever you got left, you take this times everything and add it to this times everything. So if you have a triple and a double like this, x squared plus 2x plus 7 times by x plus 5, remember you use the giant clam technique on that. If you look at the green, it looks like a giant clam. Okay. So that's how you multiply that whole thing out. All right. So here's your homework. We already did this part. And notice it says skip the domains today. Because I feel like if I tried to teach you right now the domains part, that it would be just too much. And you would go home confused. And I hate that. I always wanted you to go home understanding what we did for the day, even if we didn't get through as much. Because once you get confused, it's so hard to get unconfused. All right, so tomorrow is a tough topic. It's going to be how to do the domains for these things. The domains for these things are not just overlapping the two. When you're doing f of g of x, it has a whole different way of finding the domains. And I'm going to show you that just for a brief glimpse. The domain of f of g of x is the domain of g intersected with the domain of f. You understand all of this part. But what you aren't going to understand is that thing yet. Otherwise, it's a lot like, see this part, it's just like what we used to do for domains. We just overlap them. But this extra part is what's going to confuse you, and I'll talk about that tomorrow. That's all we need to teach you tomorrow. All right? Tomorrow's a worksheet, so it should be fairly easy. All right, so one thing at a time. Your homework is a lot of this. Find f of g of x or find g of f of x. Start in the middle. Figure out what it is, plug it in. I'm going to do the first couple with you because I'm just that kind of guy. Here we go, number 15. If you do not have a book, please go get a book. Rapido, por favor. Leave a shoe or a cell phone. Okay, so I got the problem written up here for number 15, the first one, and it's f of g of x. All right, so I look at the inside first. Always start from the inside out. So g of x. What is g of x? X minus 1. It says it right there. So I'm going to drop that in, and it's going to be f of x minus 1 now. This is how I want you to show your work. Okay, so now I got that part done. Now I can do f of x minus 1. What you write is the f function without any x's in it. F of empty spot equals 3 empty spot plus 2. And now I drop in what I'm supposed to. Final answer is f of x minus 1. Don't even try to do this. That's a thing. And that's the side I do. 3x minus 3 plus 2. Final answer, 3x minus 1. There. There's f of g of x. Well, now you're half done. Because the other part of the problem is Now find g of f of x. G of f of x. Start on the inside. Okay, Mr. P. G of f of x. Start on the inside. What's f of x? Good. I just replaced the f of x with a 3x plus 2. Okay, now the 3x plus 2 has to go into the g function. So I find the g function, which is right there. It's x minus 1. So I write g of empty spot is equal to empty spot minus 1. And drop in what you're supposed to. That goes in to the empty spot. Final answer is to actually do this part, and I get 3x plus 1. It's a lot like the other answer which we had, which was 3x minus 1. So 3x minus 1 is one answer, and the other answer is 3x plus 1. That's a function of a function. Now, I haven't showed you how to do those domains. I mean, I gave you a brief glimpse, but for right now, I know the directions say tell the domain. Skip that part. You don't know how to do the domain yet. I'll teach you that tomorrow. Okay? All right. From this point, I think once you're getting it, if you need help, please come on up and ask me. I also want to hand back your tests from yesterday.